Thank you. So let's see. Another idea I was thinking of was as far as the propulsion, in the terms of scale of propulsion, and when you're thinking, oh, okay, yeah, as far as the scale of propulsion, I'm thinking once you're actually approaching the speed of light. From what I understand, your mass is actually going to be increasing, to an almost infinite degree. So, you're going to have to expend more and more power, or have a more like a method of propulsion that's going to be increasingly efficient as you're approaching the speed of light. So, this is another thing actually I was thinking of in terms of various methods, and something I came across when I was contemplating this was the idea that there's a particle that seems to which a lot of the rules of physics maybe don't apply as much, and taking into consideration that this seems to be a particle that seems to always be traveling at seems to be traveling faster than the speed of light, and in fact can't go below the speed of light, and that's you probably heard about it on Star Trek. It's a tachyon, ladies and gentlemen. So yes, this is something that has been capturing my imagination recently, and so I was thinking, of course I've seen the some of the speculation as far as how if it's possible to envelop yourself in in a field of tachyons, whether you'll be able to to be able to surround yourself in this kind of field where you're you can bend certain rules. Maybe some of the relevant rules might not apply to you as much, when it comes to trying to propel yourself to, and maybe even beyond the speed of light. So that was something I thought was pretty interesting. And from what I understand, the methods we're using now, are mostly chemical methods that involve huge amounts of jet fuel, which is of course highly combustible, and from what I understand, to get a rocket off the ground, it takes something exceeding 4 million pounds of fuel. And of course, you're spending a lot of energy just trying to propel the fuel. If only 10%.
Kind of like the rubber band theory.
Precisely. You're not actually. To a certain extent, it's not efficient, because you're spending most of your energy propelling the means of your propulsion, and only 10% of this of this weight is actually what you're trying to get where it's going. So so just thinking about that, I'm researching lots of some other ideas that might be more efficient. Did you have any other ideas?
One more idea that might be a little more realistic at this time. I mean, with it being August 25th, 2009, would be to actually have what you would call multi-generational crew on a large-scale ship. I mean, probably ships, maybe a fleet actually, that might be the size of some of our largest cities. So we're talking about hundreds of square miles wide, long, square miles wide and long, and then of course hundreds of miles actually probably deep. I would say, well, maybe not 100 miles deep, but I would say essentially maybe, it would be on a large scale, but the smallest might be, say, 100 square miles. So that's roughly that could be like 50 one way and 20 the other as far as miles. So, and then as far as high, as far as cubically, let's say they're like the Borg, since I'm not a Trekkie, but I'm just using that for example, maybe a mile. So it'd be essentially a city or a number of cities stacked together. And the reason for that is you're looking at a trip of maybe 200 to 500 years at least to get in the direction of the closest nearest star through the Kuiper belt, and basically getting through there. And we don't really know how far, or not how far, but how deep that goes. As everybody knows, Pluto lost its planetary membership because they did find Eris, which at one point they were going to name Xena, and Eris is larger than Pluto, so they now are calling them dwarf planets. But that's in the Kuiper belt, and so basically at that point, if you can get through that, the closest star is like Alpha Centauri. That's Alpha Centauri. So basically, by say taking a multi-generational crew and traveling, you would have time to build on more technologies that are far more advanced than what we would have, say, the 200 years when we started, or 500 years when we started. So definitely by that time we'd be able to find, say, a planetary realm similar to Earth. Let's just say, unfortunately, we had, a cosmic situation or some form of radiation, some kind of gamma ray burst, or anything. It could just be basic war, just like, or we're just sick of the planet, and a group of us want to leave. That would be probably the closest realistic way of a fleet of these large city-sized ships, and I'm talking about maybe even hundreds, and like just a lot of people just leaving and traveling. But the only thing is we'd have to get used to deep space. We'd have to have gravitational capabilities, defense capabilities. We don't know what's out there. More likely we may not encounter certain beings, but you never know. So you just have to have what we come with. I mean, you don't bring a knife to a gunfight. So whatever we could come up with to explore, and essentially where will we get a lot of energy? Of course, people say, well, how are we going to do that? You can get the essentials. If you go out to any desert or any area, we're actually out of Atlanta, Georgia. You go to some of the mountains, say in an area called Kennesaw, you get everything you need as far as the basic chemicals to live off of, to build sugars, to essentially grow food, and number of energy sources, and also as far as fuel, the number of fuels you can do as far as breaking down even just basic electrolysis. You're going to have hydrogen and oxygen. Everybody knows that. Everybody did that back in 6th grade in grade school. So essentially, if you go to any kind of meteor or not asteroid, dwarf planet, anything to that effect, we could kind of go as these nomadic sort of interstellar tribesmen and women, going to different places and be able to, at that point, get enough that we need to go on to the next stop, until we get to a point where maybe we could use the actual theories that I and Dana have come up with that would be more so, somewhat science fiction. But I mean, come on, let's look at Jules Verne. What was science fiction in is science fact now, so you never know what will happen within the next 100, 200 to, of course, 500 years from now. So that's definitely, anything else, or did you want to? Okay, now that was once again our highbrow subject. Thanks again, Charles, out of Sacramento.